Hi, it's Mr. Mabry, and we're going to go over some scientific inquiry notes. Now, these are terms that you should be familiar with. You probably have learned them in other science classes in middle school and elementary school, but this is a refresher for those terms and might add a couple clarifiers to how you're going to use those terms in 8th grade science. So why don't you go ahead and title your note page Scientific Inquiry Notes. Let's jump into hypotheses. Hypotheses, they are tentative, testable predictions. Hypotheses are never right or wrong. Students are always saying, oh, I got my hypothesis wrong. Well, no, you didn't get it wrong. It's a prediction. It just means that the data you took in the experiment didn't support it. That's the more accurate way to talk about hypotheses. And then this right here is a big one that's challenging for 8th graders. We're really going to try to avoid the uses of I or we when we write predictions this year in science class. And so instead of saying, I think this is going to happen, or I predict, we're going to say this will happen, this prediction. You'll see an example here in a second to know what I'm talking about. Now, a great formula to use when you write hypotheses is the if, then, because formula. It goes something like this. If, describe the experiment. Then, you make your prediction. And then because, say something smart. If I smoke, no, don't say I. If cigarettes are smoked every day, then the chances increase for developing lung cancer because cigarettes contain carcinogens in them. If students sleep in every day, then they will do poorly in school because they arrive tardy and miss instruction. If I punch Mr. Mabry in the face, no, don't say I. If students punch Mr. Mabry in the face, then students will get detention because that's what it says in the handbook. So there you go, hypotheses, super easy. Let's take a look at the fake experiment I'm going to do for the sake of these notes. You don't have to write the following down, but it is the experiment I'm going to refer back to for the rest of the terms for these short notes. So let's say that Mr. Mabry comes along and says, you know what, I love tacos. So I'm going to see if tacos make me fatter. So he's going to develop a hypothesis that says, if people eat tacos, then people will get fatter because they are full of chunky calories. Seems like a good hypothesis. I don't know whether it's right or wrong. Let's try an experiment. But before we can do the experiment, we need to have an understanding of what our independent and dependent variables are. Independent variables, as you'll recall from 6th and 7th grade, are the I change variables. They're the variables, and here's the key. Let me get my highlighter out. These are the variables, highlighter, that occur at the beginning of the experiment. The experimenter decides how they're going to change something to see how what kind of results they get. So for instance, in the will tacos make you fatter? Tacos is what I'm changing. I'm going to give some people tacos and other people's I won't. We'll see if it makes them fatter. And the opposite of the independent variable is the dependent variable. The dependent variable is the you measure variable in the experiment. And the name comes from the fact that the dependent variable depends on the independent variable. And it's the thing that you measure at the end of the experiment. You see here again, end in comparison to the beginning. So the way that I teach my students to remember the difference is I'm going to yell, I change. And you yell back, independent variable. And then I'll yell out, you measure. And everyone yells dependent variable in a really low voice. When do we do the I change? At the beginning. When do you measure? You measure at the end. And they're easy to remember. So, again, to talk about the taco experiment, what is Mr. Mabry changing to see how it influences something? Well, he's changing what you eat, changing the tacos. And then what? So this right here, if I wrote it out, this is my IV, the tacos. That's what I'm changing, the food that you eat. And then what's the dependent variable? It is the weight of a person. It's what I'm measuring at the end. I'm measuring weight. Let's go on to another term. Trials or runs are how many times you do the experiment. That one's pretty straightforward. You always want to have lots of trials to increase the validity of your experiment. Now, experimental versus control groups, these can be sort of tricky. Experimental groups are the groups that are always different from each other. It's where you change the independent variable. And the control group is a group of individuals that are the normal group. It's the group, the word that I would underline here, it is the baseline for comparison group. And probably the best way to really understand what a control group is to go back to an example. So let's go back to this example of Mr. Mabry's doing the experiment about the tacos and your weight. Well, in order to do this experiment, he needs a group of students. And of course, he needs a group of students to eat tacos to see if they weigh more. So this group of students right here is going to be, let me get my pen out. This is my E for experimental group. They're the group of students who are eating tacos to see if they get heavier. But the question is, well, if all I have is this group of students and I feed them tacos and then I weigh them to see if they turn out to be heavy like this guy, I can see whether they gain weight or not, but maybe students gain weight anyway. Maybe just as you get older, you gain weight, and that's normal. What I need is a baseline, a comparison group to see if just students normally gain weight. And that's, whoa, come back. That's these guys right here. This is my control group. This is the group that's just my normal kids. They're just going to hang out, do what normal kids do, and not eat tacos, and we're going to see if they gain weight. So I'm still going to weigh them, but then I'm going to compare the results of these two groups. I'm going to compare these guys to these guys. And so that's why you need both groups when you do an experiment. An experimental group of students that you're messing with, and then a control group that you just keep around to compare to. The final phrase we're going to talk about is constants. Constants are unchanging. They are constant. And so that is the word you're going to want to underline in your note. They are constant, which is where the word comes from, and unchanging. And if we didn't have constants, then we would skew, such a fun word to say, skew the results. So for instance, back to this experiment, let's think of some of the things that need to be constant between this group right here and this group right here. Let's see. What are things that would influence their weight, even if not talking about their food? Exercise, because like if these guys were working out, well, of course they're not going to gain weight compared to these guys. So both of them have to exercise the same amount. So that could be the same minutes of PE. That could be that every group decides, I'm only going to go home and play Nintendo, no exercise. As long as it's constant, it's okay. What about the rest of their diet? Like, if these guys are eating tacos but also really healthy, and these guys are eating just popsicles and corn dogs, well, there goes the experiment. So that means their diet for both groups have to stay the same except for the tacos they eat. Oh, and sleep. Everybody knows that sleep as well influences what you eat. If you stay up super late, you're probably going to be eating more. Your body doesn't metabolize your food at the same rate, so sleep has to be constant. So these are the terms I'm expecting you to be comfortable with and to use throughout the year. You can watch this video as many times as you need to revisit the definitions that you wrote down or just to think through the examples, and look forward to seeing you use them in class. Thanks for watching.